All right, let's dive straight into this explainer. Today, we're demystifying exactly how Python and MySQL team up to build the foundation of, well, practically every modern web application out there. If you've ever found yourself wondering how data actually moves from a simple Python script into a permanent, secure database, you are in the exact right spot. We're going to break down the absolute core mechanics of database programming. We're taking a building blocks approach today, so it's super easy to digest. Here's our roadmap. First, the foundation of databases. Second, setting up your connection. Third, the 4 core operations. Fourth, saving and securing data. And finally, we'll wrap up with real-world uses and practices. So let's start right at the ground floor with Section 1, the foundation of databases. Before we write any code, we absolutely have to understand the core concept that literally gives life to our data. And at the heart of almost all database programming is one simple, kind of catchy acronym: CRUD, C-R-U-D. Think of it just like the digital actions you take every single day. Create is like signing up for a brand new account and inserting your info. Read is simply fetching that data so you can look at your profile. Update lets you tweak things, like changing a password. And delete removes that data entirely, like permanently closing your account. Those 4 simple ideas basically govern how we interact with all digital information. And here's where it gets cool. There is an exact one-to-one mapping between those abstract CRUD concepts and the actual SQL queries you're going to write in Python using the MySQL Connector. When you want to create, you use an insert into query. To read, you write a select query. Updating naturally relies on the update query, and deleting maps perfectly to the delete query. It's literally a perfect translation from concept straight to code. Okay, moving on to Section 2, setting up your connection. Because look, before we can manipulate any data, we gotta assemble our infrastructure, right? This right here is the essential, non-negotiable workflow you have to follow. Step 1, install the official MySQL connector for Python. Honestly, think of this connector as the physical bridge between your Python script and your MySQL database. Without it, they're totally isolated. They can't talk. Step 2 is using that connector to establish the actual live database connection. And finally, step 3 is laying down your table structure inside the database, basically prepping the room so it's ready to receive your information. All right, bridge is built. That brings us to Section 3, the 4 core operations. Time to lay down the bricks and execute the commands that actually do the heavy lifting. First up, the create operation. This is literally the birth of our data. Using that insert into query we looked at, this operation lets us push brand new records directly into our tables. And what's awesome is that Python lets us be highly efficient here. We can insert a single record one by one, or if we're in a hurry, we can batch insert multiple records all at once to rapidly populate our database. Now, what's really fascinating here is how we can completely tailor our read operations depending on what we need in that exact moment. When you run a select query, Python gives you a couple of really handy options. You can pluck out one single specific record, like just one user's profile, using the fetch1 method. But say you need to run a massive report of every single person in the system, you'd just grab the entire list of rows using the fetchAll method. You can even specify exactly which columns you want back. Of course, data rarely just sits there forever, right? It evolves. When it needs to change, the update operation steps in to target specific, already existing records and modify them. Whether it's a user just updating their home address or an HR system processing a salary bump and a brand new job title simultaneously, this operation handles changes to single or multiple fields without breaking a sweat. And finally, we have the delete operation, the destruction phase. This is what you use to safely remove outdated or just flat-out incorrect info. You can be super surgical and remove one very specific record, or if you need to completely clear the board, you can wipe out all the records in a table entirely. It's an incredibly powerful operation, so yeah, it definitely requires some precision. So the big takeaway here is that all of these CRUD actions are powered by a very specific set of built-in Python methods. To run a single query, you use execute. Got a bunch of inserts? That's execute many. We just talked about fetching with fetch1 and fetchAll. And as we're about to see, you command the ultimate lifecycle of your data using commit to save and close to shut the door. These 6 methods, they aren't just code. They are basically your primary database toolkit. Which brings us to Section 4, saving and securing data. We've laid the bricks, sure, but if we don't mortar them together securely, the whole app is at risk.
And look, it is incredibly common for beginners to write absolutely perfect Python code, run their script without a single error, go check their database, and find exactly 0 changes were made. Which naturally leads us to this huge, vital question. What exactly is con.commit, and why is it absolutely critical after inserting, updating, or deleting data?
Well, the answer is simple, but it's essential. Without calling commit, your changes are simply not permanently saved, period. The con.commit method is basically the dramatic savior of your application. It is your ultimate save button. If you run an insert, update, or delete query, and your script just ends before commit is called, all that hard work just vanishes into thin air. The database simply discards it. And hey, just like commit acts as your save button, parameterized queries act as your ultimate shield. I can't stress this enough. Executing your operations this way is vital. By using parameterized queries, which is kind of like using a secure fill-in-the-blank form instead of just hastily gluing text strings together, you are actively preventing SQL injection attacks. It is the definitive safe way to execute operations and essentially locks out malicious hackers trying to steal or destroy your data. All right, let's step back and look at the finished building in Section 5, Real-World Uses and Practices. How did these 4 basic operations actually power the digital world we use every day? Take a standard human resource management system, for example. It brilliantly shows how that abstract CRUD acronym becomes completely tangible. When an HR rep clicks Add Employee, the backend is firing off a create operation. When they hit View on that employee's file, that's a read operation. Giving them a well-deserved raise is an update operation. And when someone eventually leaves the company, hitting Remove Employee triggers the delete operation. It's everywhere. Now, if you want to transition from writing scripts that just work to writing actual professional-grade software, you've got to adopt these best practices. First, always wrap your queries in try-except blocks. Proper error handling means if a database randomly goes offline, your app handles it gracefully instead of crashing. Second, always use that close method to properly shut down your connections when you're done, which stops nasty memory leaks. And third, use a modular code structure. Keep your database logic cleanly separated from the rest of your app. Once you've got this basic CRUD workflow down, your journey naturally leads to some really cool, highly advanced database concepts. You're going to want to explore joins to seamlessly combine data across multiple tables, transactions for those tricky multi-step updates, stored procedures, and indexing for raw speed. And eventually, you'll probably start using ORMs, object relational mappers, like SQLAlchemy or the Django ORM, which honestly automate a ton of the heavy lifting we've covered today. The reason mastering this is so unbelievably crucial is because CRUD operations are the absolute foundation of modern programming. From massive ERP systems and your personal online banking portal to huge e-commerce sites, job boards, and complex backend APIs, every single one of them relies entirely on the exact create, read, update, and delete workflows we just walked through. Knowing that just 4 simple operations hold up the entire digital world, that is incredibly empowering. You now have the exact blueprint you need to manipulate the digital world safely and effectively. So the only question left for you is, what piece of software are you going to build first? Dive in, start experimenting, and I'll catch you on the next explainer.